Mars is far from Earth. The vast distance, stretching up to 400 million kilometers at its widest point, makes real-time control of machines impossible. Any command sent from Earth can take between 5 to 20 minutes to reach the red planet. That's why autonomous robots will be humanity's most crucial allies in exploring, building, and surviving on Mars. These machines aren't just remote-controlled vehicles. They're intelligent systems capable of making decisions, adapting to terrain, and responding to unexpected situations. They will act as the eyes, ears, and hands of colonists in environments too dangerous or distant for humans. Take, for example, robotic rovers like NASA's Perseverance or the European Space Agency's Rosalind Franklin. These rovers are already exploring Mars, conducting scientific experiments, mapping terrain, and even collecting rock samples for future return missions. But the next generation of robots will be far more advanced. Picture agile robotic dogs like Boston Dynamics' Spot, outfitted with sensors, cameras, and AI navigation systems. These robots can autonomously navigate rocky landscapes, climb over obstacles, and even recover if they trip. They move with eerie grace, almost as if alive. Such robots will be invaluable for inspecting habitats, scouting paths, and transporting supplies. Their autonomy means they won't rely on constant human input. Instead, they'll assess their surroundings, make real-time decisions, and execute tasks with high precision. Why is this autonomy so important? Because of the communication delay between Earth and Mars, direct control is inefficient. By the time an operator reacts to an obstacle, the robot may have already collided with it. That's why robots on Mars must be equipped with advanced AI that allows them to process data, learn patterns, and anticipate dangers. Imagine a robot tasked with building a structure. It scans the area, selects a flat surface, avoids unstable ground, and begins placing modular blocks. No joystick, no micromanagement, just efficient, calculated execution. This is the future of planetary construction. AI-powered drones may also play a critical role. These flying machines can survey large areas quickly, map terrain in high resolution, and even detect signs of water or underground structures. Combined with ground robots, they'll form a comprehensive robotic ecosystem, covering air, surface, and underground operations. Inside Martian habitats, robots will assist with maintenance, repairs, and daily operations. Imagine a spider-like bot checking airlocks for leaks, or an articulated arm fixing a hydroponic system without waking the sleeping crew. These aren't fantasies, they're prototypes under development on Earth right now. There's also the possibility of robotic exosuits, mechanical frames worn by humans to enhance strength and endurance. These suits could assist with lifting heavy equipment, performing spacewalks, or even adapting to low-gravity conditions. With AI assistance, these exosuits would monitor the user's movement and adjust accordingly, reducing strain and improving safety. But it's not just about hardware, it's also about software. AI assistants will monitor life support systems, manage energy usage, schedule tasks, and even provide psychological support. Think of them as Martian co-pilots, helping humans focus on exploration while they handle the routine and the risky. Infinity. Beyond believes that the collaboration between humans and intelligent machines will define our success on Mars. These robots won't replace astronauts. They'll empower them. And the more we learn about how to deploy and integrate AI on another planet, the more advanced our systems will become here on Earth. Imagine applying Martian robotics to disaster zones, deep-sea exploration, or hazardous industrial sites. The technology we develop for Mars will echo back to benefit all of humanity. Of course, there are risks. AI must be carefully designed to avoid unpredictable behavior. Malfunctions on Mars could be deadly. That's why redundancy, safety protocols, and human override systems will always be in place. Robots may be smart, but humans remain the moral compass. As we push further into the cosmos, robots will always go first. They scout the way, pave the path, and prepare the environment. But on Mars, they'll do more than that. They'll live alongside us, work beside us, and maybe even teach us new ways of thinking. Because in many ways, robots reflect who we are. Our ingenuity, our dreams, our desire to explore. And when the first human steps out of a Martian lander and looks across the red horizon, they won't be alone. Somewhere nearby, a robot will be watching too. Its sensors scanning, its gears humming, its presence a silent promise of cooperation between biology and code.